Thank you everyone for coming. This is our session on automating cloud recovery. It's the only way to be sure. I'm Ashley Neely and I'm a senior solutions strategist formerly with VMware. I was part of the OVH acquisition of vCloud Air. So I will be going over a little bit about OVH today. And I'll also be reviewing the environment that was configured for this demonstration of a disaster, and also the vCloud Air configuration. And then of course I'll be going over when everything goes down at 2 a.m., because it always is 2 a.m. when everything goes down. I have a demo of a full failover, and the application that is monitoring the VMs on-premise is called Mother, and we'll review what went into making her. And then we'll expand a little bit on the idea and discuss new possibilities that OVH will be bringing to disaster recovery solutions to cloud. So who is OVH? OVH is a global hyperscale cloud provider. We are the 5th largest cloud provider in the world, and we are #1 in Europe. We have a data center capacity of 1.3 million physical servers, and we have about 260,000 deployed servers currently that are in active use. At the beginning of 2016, we had 20 data centers in 5 countries, and approaching the end of 2017 here, we have 27 data centers in 11 countries. And by 2020, we're expecting to have about 50 data centers worldwide. We have our own fiber that we own that connects all of our data centers, and that network has 11 terabits per second, and we have 32 points of presence that customers can connect into from on-premise to get into our network and connect into our data centers. We have 1.2 million business clients, and that is across 138 different countries. We have over 19 years of experience building and managing servers, as well as our own data centers. So here are some examples of what we have built. Some of our data centers are built entirely from the ground up and designed entirely by us, while some of our other buildings have been acquired. You can see in the top middle picture there, that's one of the structures that we would put into data centers to minimize the air circulation needed for cooling, which leads into that we use 30% natural air cooling and 70% water cooling. So we have no air conditioning in any of our data centers. With all of the infrastructure that we build, which includes our own racks, our own server chassis, as well as the other data center pieces, we have a variety of services. So we have private cloud options that are all built upon VMware. So some of you may be familiar with the vCloud Air options, which are dedicated cloud, virtual private cloud, and disaster recovery offerings that include disaster recovery as a service and dedicated disaster recovery. In addition to that, OVH also offers a full SDDC stack, which includes an NSX configuration as well as vSAN. We also offer a public cloud infrastructure built upon OpenStack. And with that, we have all of the OpenStack APIs, the command line utilities are accessible, and we have the full automation compatibility that anyone that uses OpenStack would be looking for, as well as that scalability. We also have the ability to provision bare metal servers for customers. So anything that you guys may have, bring your own license or non-virtual workloads or proprietary software, we can put on bare metal servers for you. In addition to owning our own fiber at that 11 terabit per second network, we also offer anti-DDoS, which is built into that networking service that we already have. We also allow customers to set up their own private VLANs, so within any environment setting that you have the option to add VRAC to that, which will give you 4,092 VLANs, and you can connect that across any data center and any of your chosen offerings to use. So going over what the scenario is here, we have on the left-hand side what is the on-premise. We have some VMs near the top in that building icon that are not replicated workloads. Those are very low-tier applications we don't really care about. If everything goes down, they're not a priority at all. Below that in the dotted line, we have the VMs we care about replicating. In this scenario specifically, I only have a single subnet there, so it's a 10.10.10.0/24. And you'll see that we have that extended through the L2C across that green dotted line, which is the layer 2's network switch provided by Hybrid Cloud Manager, to a layer 2 concentrator on the other side. That allows the VM that's labeled mother there at 10.10.10.99 to be on the same subnet and communicate on-premise with anything on that subnet across the layer 2 connection. So in addition to mother running over there live, we also have other virtual machines running workloads in the environment, and we also have the replication seeds that are there and ready to go if a disaster should strike. So the layer 2 extension capabilities are provided by Hybrid Cloud Manager, which you can see in the middle square there, labeled with its IP. Everything in our management stack is running on a 192.168.1 subnet. So you can see the hosts are there, as well as vCenter and vSphere replication. And how this works is vSphere replication will send the replication data up to the cloud gateway, which is deployed by Hybrid Cloud Manager. And the cloud gateway will then send it over to be optimized to be sent across to the other cloud gateway. So that WAN optimization can reduce the transfer time by up to 70%. So Principal Technologies did a very good review of HCM if you're interested in looking at that. It's a quick Google. That showed that 70% reduction across a lot of their workloads that they were transferring. So anything that would take 10 minutes was taking them about 3. So that's the setup that we have here. All right, so these are the VMs that are currently replicated. This is the vSphere replication view within the web client. So I have 19 VMs that are replicated, and I have 3 defined different tiers. In order to keep things relatively simple, I define the tiers just by OS or the application being used. So my tier 1 application is actually an Elasticsearch cluster that's running Kibana and Logstash. Logstash is just ingesting data about CPU usage, RAM usage, and network traffic by all the VMs in the environment, well, specifically on this subnet. And then beyond that, as my tier 2 applications, I have CentOS machines that are the COS labeled ones. And then I have, as tier 3 applications, some Ubuntu server VMs. The important thing that I wanted to point out here is I exported this list of replications to build a CSV for my monitoring. You should probably have a lot better monitoring than I did here. My goal was not to show good monitoring techniques, but rather to show what you can do with the API. So my monitoring technique of choice was to ping from the mother VM that is in vCloud Air to the VMs on-premise across the layer 2 extension. If that network connectivity goes down, then mother automates the failover, starting with the tier 1 applications, later to tier 2 and tier 3. Of course, there are better ways to do this, and you should do better ways than this, but that was just to show the quick and simple way that you can set something up like this. So here is the vCloud Air side. We have the VMs just showing that their replication status is okay. We have different RPOs set per tier, so our tier 1 applications are 15-minute RPOs compared to the tier 2 VMs that are 1-hour RPOs. So for our demo, the way I simulated the failure was just to unplug the switch that was handling my VLAN 2, which was running all of the 10.10.1 addresses in that /24. So I unplugged that. Mother lost all connectivity to anything on that subnet on-premise, and then started failing over. So the failover defined time is 1 minute of downtime, and tier 1 applications fail over. 5 minutes of downtime, tier 2 begins to fail over, and 10 minutes of downtime, tier 3 begins to fail over. I did the application in a single thread, so it actually pauses per VM to make sure the failover is complete before continuing on to the next. Once again, that's something you would definitely want to optimize if you were to implement any of these in your own, or any of the APIs or SDK in your own environments. So Kibana is monitoring all the things, and we'll be able to see after the failover when Kibana comes back up. We can connect to it on-premise, even though it's now running in vCloud Air. It's using the same IP scheme that it was before, because there's no re-IPing needed when you're running the layer 2 extensions. And we'll be able to see where that data was lost. So up on the left-hand side, we see the Ubuntu server that we have, which is just one of our tier 3 applications. And then we have the Elasticsearch cluster as the other 3 VMs. So there's where one of them goes down, and then the second one is going to go down in a second here. And then Kibana will lose all of its visualization because it's no longer supported by an Elasticsearch cluster. Here is where we're watching the log file that's generated by Mother. We can see the pinging is at 100%, and then it quickly drops to, is at 0% packet loss and quickly drops to 100% packet loss. At which point on the left-hand side in the vCloud Air window, you can see recoveries start to happen. So we're starting with our Elasticsearch 02, and then Elasticsearch 01 will begin to fail over, and then our Logstash VM. On the lower right-hand side, I've just done a cat on the file that is tracking the VM name, the IP address on premise, which will be the same IP address when it comes up in vCloud Air, and the replication UUID. We'll go through how I got that number, but it is something that you can pull using the SDK that's available, and then just paste it all together in the way that I did. Hopefully, once again, you'll have something a little bit more robust to do. So here you can see we're failing over the last of the Elasticsearch cluster VMs, and that one is now recovered. At this point, our CentOS VMs are going to start failing over. Every single failover, it's reaching out to vCloud Air once it reaches the threshold set for the tier of that application, and it's logging into vCloud Director. It's retrieving the replication status and then telling it to go ahead and fail over. Obviously, this is quite sped up. Overall, this whole process took about 42 minutes, once again, because it was single-threaded. So once this one VM started failing over, no other VMs were going to fail over until that one completed. Here you can see we have more packet loss that is happening. So it's going to the next round of failovers here with the Ubuntu servers. And at the end, whenever you have this, if you were running the SDK, you will get a full status of each VM, which will show up here on the end of the Ubuntu servers. You'll get to see that. And we're almost done here. So just as a note, as I mentioned, it is single-threaded. It's doing single VMs at a time. You can do batches of 20 at a time in our multi-tenant environment, and you can do more than that in our dedicated DR environments. So here you can see the status where the VMs completed failing over. And here's the Kibana window that came back up. So we're connecting to it by its original IP, and we're pulling up the dashboard again that we had, and you can see where the data stopped being shipped to Logstash because everything went down on that network. So for the Elasticsearch cluster, you can see the downtime from when everything went down until it was over in vCloud Air and everything was back up and communicating to it again was about 15 minutes. While you can see it was about 40 minutes for the tier 3 application that's up on the left-hand side there. So Mother was built off of vCloud Director APIs and the Python SDK that was built to handle the sessions and parse the XML. So here is just the simple login, going with Postman, just to kind of show what sort of information is available specifically for what we just did. So here it's just a basic login. You have your username, your password, and you'll get a xVCloud authorization token in return, at which point you'll add that to your header. We have the API version 5.7 that we're using for the vCloud Director APIs, so that is also in our header. And other than that, we can go ahead and move forward and look at the body. Within the body here, it returns an org or a VDC, depending on what level you are at. So for anyone that hasn't used vCloud Director, there's kind of the big bucket of all your resources, which is your organization. And then below that, you can create virtual data centers or VDCs. So you can carve out a section of those resources and define it to that VDC and say this has, 10 vCPUs out of the 40 vCPUs that I have available. So in this case, we have a single org, which is named DR. You can have multiple orgs here, however. If we go ahead and get that org with the UUID that is provided, you'll see we have 2 VDCs in the environment. You can have more than that, and they will always appear in alphabetical order, which does come into play later as we're reviewing the SDK. Here we have a DMZ and a DR VDC. If you go ahead and do a get on the DR VDC, you'll see that we have href for our replications. Once we go to that, we have a full list of all of our replications, which include the CGID, which is the replication UUID that we will need to use in the SDK to perform a failover per VM. You can also bulk failover every single VM in the environment, but since we wanted to do it by tier in this case, we wanted to pull the CGIDs for each replication and failover accordingly. I need to match that to the on-premise IP addresses, as well as the VM names, so that everything is in sync between on-premise and cloud. So when I go ahead and pull that replication with the CGID for the href and perform a get there, all that information is then pulled. So you can see there's the VM name there, and there's also other actions we can perform. We can perform a test failover, we can do a full failover or planned migration. And so what we're going to do next is go ahead and look at the SDK. So this was written by Scott Schaefer. He is a full stack developer for OVH, and it's just a simple pip install vCloud Air. I do have highlighted here the GVR session and dedicated DR modules, and that's just because those are not available if you pip install vCloud Air. So that is not actually published and accessible yet. So I am going to go over the differences in those modules a little bit. So if anyone here has a dedicated DR environment they're going to use compared to a multi-tenant environment, you'll know what those differences are. So this is my little script that took a couple minutes to just type up, and it runs everything. Overall, I'm not at all a programmer, and this took about 2 hours for me to modify the modules to log in appropriately to the dedicated DR environment, as well as write up this little script. So the first thing that we're going to do is look at these first lines here. So we have a session that's created using the 5.7 API that we were also using when querying via Postman. Mother is the username, and then the blocked out portion there would be the password. So you just pass that to SES and create your session object, and then from there you can go ahead and log in using that. You just paste in your vCloud director URL. This does change depending on what type of environment you have. For the dedicated environments where you have your own VCD, you have a URL like this. For the multi-tenant environments, you will end up with a URL that has a long UUID similar to what we've already seen at the end of that. And then we pass along the org information, which in our case is DR, as well as the VDC name, which is also DR. And once we've done that, we have a full session object that we can then, that we can then use. I am bringing this up simply to show these are the instantiated variables when you create a session. And the difference here is just that we do have the VDC list at the end, which is a dictionary rather than just a single variable with the, with the UUID. This will change in any of the other environments we have because there's only a single VDC. So you basically don't need to pass that third variable to define the VDC because it always is the same as the organization. So here we have our login, which is where you're actually passing that information to. So the auth header is the XVCloud authorization, as you can see. We're setting all of the headers up there. We're creating the username by the information that was provided. And then we're going to go ahead and make that request to the API sessions to pull the session. And then we'll check and make sure that the response is in fact 200, at which case we will set the header appropriately to also include the session token that we received. Here we're going to look at all of the UUIDs and figure out which one is the one we actually need. So that is this step here, which will lead over to our parse org UUIDs. So everything from vCloud Director is in XML, so all of your responses are XML. So in this example, we're using element tree to parse that, and then we are creating response as an empty list, and then we're iterating through all of it. So for each organization that we find, which is defined by the link type as vcloud.org plus XML, as soon as we find that in the type, then we go ahead and check that link and make sure we can get a response from it to get the link for, to actually write that link to the file or keep track of it. And then we're going to go to the next section, which is checking those links for the VDCs. So for each of those links, we're going in, we're saying what are the VDCs, and then we're appending that to the VDC list, a dictionary that was shown up above. And then that is what we are returning. So we're kind of doing two steps in one here. And I should have clicked through this, but there we go. So that's returned. And then UUID will then look through that UUID list and pull out the correct VDC name and set the UUID to that. That is where we have extra things that you wouldn't need in the other environments. As I mentioned, the VDC and the org name are exactly the same in everything else. So this entire section can basically be removed. Once we have all that information, we write that down so that we can use it in the object, or that is stored in the object itself. So our auth headers, the token, the VCD URL, which we'll manipulate in different ways, and we have the API version, the UUID, and the VDC name. Of course, then we do print the session data at the very end there, which is just basically to confirm that everything happened as it was supposed to happen. So going back to here, now we need to take that session object and make a DR object out of it, which is what we're doing with that first line here on line 16. Once we've done that, we can go ahead and retrieve replication data, which is just stored in memory. It's not written anywhere until you dump the replication details, which is our third line on line 18 there. Once you dump the replication details, you'll have a CSV file that's in the local folder, and we can then go ahead and parse the multiple CSV files we have from the replication appliance and now from dumping the replication details. So here we're just going to start utility, and we're going to go ahead and parse the VCA UUIDs, which is just a little method that was created to blend those two CSV files together that are in the local folder. Once again, not the best way to do this. You will probably do something much better, but I'm just showing that we can literally write this in about 10 lines of code. So the next bit is that it will go to this. It's going to open the export list.csv, the details.csv, which is the dump of the replication details that contains the VM names and the UUIDs. And then we are going to create a temp file that we're actually going to write to. And then we're going to iterate through each line of the export list and then find a matching VM name that is in the replication list dump. And then we're going to put that UUID into the open column in export list, which is row 8, which actually, let me get to the bottom there. So at row 8 at the very bottom here, that's where we're writing the VCA UUID to export list.csv, and then at the very end, we're going to just copy that to export list. Pretty quick and dirty. So here, we are going to go ahead and start the script. That's just a little bash script running in the background at this point that runs the ping utility. I didn't put the code in here exactly. Well, I didn't put a screenshot of it in here. This is what it says. So it imports monitor, and then it starts the ping utility on the startup object that's created. The ping utility itself runs very similarly, where we have CSV files that we're reading from and one that we're writing from. Within the CSV file, we are going to look at the rows for host name, which is the IP, how many times a ping has failed to return, and what tier that application is in. So the response is going to run that code and return either a 0 value or 1. If it returns 0, then the fail count stays at 0. If it, and then it writes to row 6 as 0. If it returns anything else, it iterates the failure count, and then depending on the failure count, it defines the tier the application is in. So we have this running every 15 seconds. So if it fails twice, that's 30 seconds. So if it fails twice, that's 1 minute for tier 1 applications. If it fails 4 times, that's 2 minutes for our tier 2 applications. And then if it fails 8 times, that's 4 minutes for tier 3. And then when you count in the actual failover time, we get to our 1, 5, and 10 times that were mentioned previously. And then of course, as we're exiting out, we have an else statement to write the fail count to row 6. At which point we copy the temp CSV to the export list. Here you can see what happens when a successful failover occurs. In the log file, you'll see that we have the lost pings, then we have the session data, which is it authenticating with vCloud Air and getting ready to failover, and then you see the percentage of the failover and the VM name as it's completed. So expanding on the idea, we have other vCloud Air use cases and environments. We have shared cloud environments, which are usually designed similarly to this. You can have just the disaster recovery environment, or you can have a VPC with always-on workloads in front of the disaster recovery environments. In our multi-tenant, we do not have the ability to run live workloads next to replications, which is why here you see the 2 environments. The backup IPsec VPN would allow you to have the same exact IP space in the multi-tenant DR environment, and then if your connection to on-premise goes down or there is a disaster, you tear down that IPsec VPN and pop up your backup VPN. And here's a model that's a little bit more expanded off of what I was doing that we looked at earlier. As you can see, we have HCM deployed, we have layer 2 networks that are stretched, we have some networks that are not stretched, and we have a direct connect connecting us to the dedicated disaster recovery environment. We also have a dedicated DMZ SID. So that's going to be at least 3 hosts that are dedicated to the customer alone. And behind that, we have an additional dedicated cloud and a VPC, which is a shared environment. So for OVH capabilities, we have NSX that's available with the SDDC stack that was previously mentioned. We are able to, we are able to expose the NSX API so that you can manage that way, or you can manage it through Manager, of course. vSAN is also available in those environments, so this really is a true data center replacement option. And where this comes in as a DR solution is that we can then deploy vSphere replication and replicate to vCloud Air from there, or we can also deploy Zerto. And that's Zerto managed as a service by OVH. So it does connect a PCC environment with the full SDD stack to another PCC environment. And you can replicate from one to the other. Currently, we cannot do with Zerto on-prem to an OVH PCC stack. So that's where the vCloud Air solutions would be the alternative instead. We also have VRAC, which interconnects all the OVH environments, as I previously mentioned, and customers can purchase a direct connection or a VRAC connection into any of the points of presence that we have, and then layer 2 connect from on-premise to their OVH environments, and from there access everything over layer 2. OVH has built out robust APIs for every single service they have, and we are currently working on getting vCloud Air services integrated and in here as well. And where this comes into play for DR is that a lot of times you don't want to purchase all your compute up front. You don't want to pay for a duplicate of your on-premise environment that you're not going to use. So in this case, you can run in a degraded state with the amount of compute you need as a minimum, and you could systematically order through the OVH APIs additional compute, whether you're doing dedicated servers, whether you're doing the PCC stack, or whether you're doing a vCloud Air environment. Once that's integrated into the OVH APIs, you can then automate the ordering and the purchase and the configuration of additional compute for your DR environment only if there's an actual disaster that occurs. So here we have some of the options that are available with VRAC. So you can add and remove projects for OpenStack as well as other services, and you can do some configuration from here as well. And you have the same options for the PCI environments, which is our cloud project, and also within dedicated cloud. So that's just an example of some of the things that are available that you can change with the OVH APIs. And at that point, get from a simple disaster recovery solution where you're replicating exactly what you have to something that responds to an actual disaster. And that is what I have. Do you guys have any questions? All right. So if you'd like to see some of the stuff that we have and other demonstrations we have, both the vCloud Era and OVH products, we are located at booth 406. And you can also see some of our other sessions. So tomorrow there is one called Shields Up, Building a True Security Barrier in the Cloud at 2:30 to 3:30 p.m. And then we also have one about clearing cloud confusion that is still going to happen tomorrow at 2 to 3 p.m. Thank you very much.